And there we are. Today we study parametric equations. Equations who share a common parameter or variable. Parametric equations allow us to really manipulate a lot of different situations and things that normally wouldn't be functions for us, but are in this situation. So for example, suppose that I hit a softball, okay? Deep right center, okay? Going way, way back, way back, way back. What's changing with the ball? What's changing? What's that? No, say it. It doesn't matter. Just say it. Okay, we have a scaredy cat. All right, so what do we got? What'd you say? Speed. Speed's changing, right? Probably the velocity starts greater than when it ends. Okay, probably. Yeah. What else changes? Position. Okay, so the location horizontally and the location vertically, right? So I get it's moving horizontally. It's also moving vertically. That's changing. There's something that's changing as well, and it's always changing. Whether we hit a ball, whether we ride a bike, there's something that's always changing that many things in the world are connected to. There's many things. Time. Time is that variable that often relates most every single problem in the world connects back to time, right? As time goes by, things change. And so these two equations, this x and this y, are connected to time. So as time advances, so changes the x and the y value. And as you hit that softball, say it stays in the air for 4 seconds, as that time goes by from 0, 1, 2, 3, 4, both the horizontal position and the vertical position change, right? And we could write an equation for the horizontal position dependent on time. We could write an equation for vertical position dependent on time, as you see here. So we're just going to start. I've just made up a few values here. We're going to start with -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And one thing you want to be able to do is create a table of values, okay? And right now I've created a table of values for -3 is less than or equal to t, which is less than or equal to 8. I've used that as my domain for t, okay? Those are the values I've chosen to use. If the problem tells you use from 0 to 2, then use 0, 1, and 2, okay? But I've chosen to use from -3 to 8. And now I'm just going to create a chart here. I'm just going to, in order to get x, I have to square t and subtract 3t. So what's -3 squared? 9. And then if I plug in, let's see, -3 times -3 is 9, and 9 minus 9 is 0. So x would be 0 in that situation. I plug in -2. -2 squared. 4. And then -3 times -2 is +6. So 4 plus 6 is 10. Now I plug in -1. -1 squared, 1, and then it will be a -3 or +3? +3, so I get 4. I'm sorry, this first one isn't 0. What's the first one? 18. It's 9 plus 9, so +18. What do you get when you plug in 0? You get 0. What do you get when you plug in 1? 1 minus 3 or 1 plus 3? 1 minus 3 is -2. Now I plug in 2. 2 squared is 4. Will be a -6 or +6? This will be a -2. Plug in 3. 3 squared is 9. Be 9 minus 9 or 9 plus 9? 9 minus 9 is 0. And plug in 4. 4 squared, 16. 16 minus 12, 4. 5. 5 squared is 25. 25 minus 15, 10. 6 squared, 36. 36 minus 18. 18. 7 squared is 49. 49 minus 21. 28. I'm going to plug in 8. 8 squared is 64. And 64 minus 24, 40. We compute our x values. Let's compute our y values. These go a lot quicker. Y says you just take the time and you subtract 1. So what do you give you to take the time and subtract 1? -4, then -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Yeah. I'm going to go ahead and make a chart. It looks like my x values go all the way back to -2. They go up to 40. So I'm going to have to make like 10, 20, 30, 40. So we're going to go 40 there. We're going to go 10 here. And then for my y values, I'm going to go all the way up to 7. So we'll go like 2, 4, 6, 8. And I don't plot time, I plot the x and the y. So the x value, I plot 18 and then -4 for y. So 18 and -4 for y. $10 for x, -3 for y. $4 for x, -2 for y. $0 for x, -1 for y. -2 for x, and 0 for y. -2 for x and 1 for y. 0 for x and 2 for y. 4, 3, 10, and 4, 18, 5, 28, 6, 40, 7. What shape do you get? Sideways parabola. Does that pass the vertical line test? So in terms of x and y, it is not a function. However, we have managed to produce a function. Or we managed to produce the graph using our parametric equations as functions. Function of time. Take out your calculator. And I'll give you $1 if you give that to your mom for Mother's Day. Mom, you get a 3-petal flower. I think that's kind of a good idea. Go into mode. And instead of function or polar, go to parametric. Instead of degrees, select radians. And go into your y equals. It's stored in there from last year at this time. I'll clear it out. And so you can see x sub 1 of t. We're going to write t squared. So t squared minus 3t. And we're going to write t minus 1 for the next one. Everybody okay with what I got? I'm going to zoom 6. Is that the same graph as what I have? Kind of. I'm missing part of it, aren't I? Yeah. This one goes all the way up to 40, where this probably just goes up to 10, doesn't it? Let's go in our window and see what you can control. Don't worry about the T min or T max or T step. I don't need to get too confused there. Well, the T min, that's our minimal time. What is our minimal time here? -3. I'm going to put in -3. What's my maximum time? 8. Don't worry about the T step. My X minimum, it looks like, is -2. But on my graph, it looks like if I created, say, a -10, that would be enough. If I create an X max of +40, that should be enough. A tick mark of every 10. My Y minimum was down to -8. My Y maximum was +8. And my scale was every 2 tick marks. Now I press graph. Is that the same graph that I have? Yeah. It's actually interesting. You can control the graph dependent on what time values you choose. Suppose you're like, you know what? I don't want to go all the way up to 8. What I would like to do is I would like to go up to 3. And so you go from -3 to 3. It will stop it for whatever the third time value is. Suppose you want to produce more of the graph. Then instead of starting at -3, you start at -5 and produce all the way up to, say, 6 or something like that. And it will produce that section of the graph. You can actually control which elements of the graph get produced and which elements don't. So parametric equation is very powerful in being able to relate to the real world. Now, first thing you're going to have to be able to do is you're going to have to be able to sketch a graph by simply creating table values. Can you do that? Second thing you're going to have to be able to do is to write an equation by eliminating the parameter. So I have x is equal to t squared minus 3t, and I have y is equal to t minus 1. I would like to eliminate the parameter. The parameter is t, or time. So I want something where the value of t as a variable does not exist anymore. Anybody think of a way I could get rid of t? Substitute. So solve y plus 1 is equal to t. So now I know that t is equal to y plus 1. What can I do with the y plus 1? Drop it in there and there. So now you have x is equal to y plus 1 quantity squared minus 3 times y plus 1. What is y plus 1 quantity squared? Minus 3y minus 3, or x is equal to y squared minus y minus 2. Horizontal parabola, is that what we just sketched? There we go. Not too bad, huh? You should also be able to plug things into your calculator and describe the graph that we get. This one says 3 cosine of t and y equals 3 sine of t from 0 to pi. It says describe and graph the curve. So let's go to our calculators. We go into parametric form. And for x, I enter in 3 cosine of t. And then for y, I enter 3 sine of t. Notice it says we go from 0 to pi. So as I go into my window, it might be helpful to just zoom standard, zoom 6 first. and then go back to your window and adjust your time. The time is from 0 to, notice how it defaults to 6.28. What is 6.28? 2 pi. So if we go to pi, what do you think it's going to do to the curve? Just show half of it. As you can see, it produces a semicircle. If it looks like it's longer than it is tall, again, it's because it's not squared properly. If I zoomed as a square, number 5, that would produce, that more perfect view there. I think actually if I zoom in at that point, it will help me out. And try to, too far in. Oh well. Something I think is kind of fun here is if you take this view and you decide to go into your window and you change your t-min, say you start at pi over 4, and then you want to stop at, say, 3 pi over 2. You see what the graph does is kind of cool. It's going to start up at pi over 4, and it'll draw all the way down to 3 pi over 2. Like you can control any aspect of the graph you want, which is kind of neat. Flip it over. Why don't you plug this into your calculator and describe what you get? Okay, go ahead on your own, plug it in, describe what you get. Go. Ooh, there's no parameter here, so I go all the way to 2 pi in this situation, and or for my domain, what shape do you get? An ellipse, yeah. Notice how far is it stretched horizontally? 5 units, right? And it's stretched then 3 units vertically. And so, we just talked about ellipses and hyperbolas. So instead of writing them as x and y functions, you can write it using t as a parametric equation as well. This last one here, before we get to our final problem, we're just going to graph this one. We're going to graph cosine squared. So I'm going to put parentheses cosine of t, and then I will square it. And I'll graph sine. What? Here? So that's what this means. That means cosine of t, quantity squared. Yep. That's what that means. And I'm going to zoom standard, and we'll see what we get. Ooh, I don't see too much. Zoom in, yeah. How? Zoom as? I like to zoom as a box. As I zoom as a box, I'm gonna, drag my cursor up, and I'll press enter, and it boxes that in place. And then I say go down and over, and it's gonna create that cool window. So I get to control my zoom. I like to do that. What shape do you get? Yeah, sideways parabola. Vertex is like 0. I'm sorry, 1, 0, and it heads off to the left. Yeah. You graph all sorts of things that we wouldn't consider functions in a normal situation, that when you include a parameter, now they become a function of time. Our last problem, find parametric equation for the line with the given properties. So a slope of 4 and passes through the point -2, 5. This is easy peasy if we're dealing with x and y, okay? For example, y minus y1 is equal to m times x minus x1, right? And so the equation for our line would be simply y minus 5 is equal to 4 times x plus 2. And then we could turn that into slope-intercept form. Everybody agreed? Okay. But it doesn't say to write an equation in rectangular form, it says to write an equation of parametric form. So that means it needs a value of t. Okay, it needs a value of t. Everybody got that? So to try to help you understand, there's multiple ways of doing this, and people get frustrated during this time. This is definitely something that people don't always see and connect with and understand. So I'm going to do my very best, and hopefully it works, but might not. Sorry. I'm going to draw my graph. I'm going to get a graphical view of this just because I think that helps people understand what the heck is going on as I try to write this equation. It looks like it passed through -2, 5. So I'm going to go back to 1, 2. I'm going to go up 1, 2, 3, 4, 5. And that's where my point starts. And remember, we have to get an element of time in here. So I'm just going to say that's where I start, and then I'm going to advance 1 unit in time. So as I advance to the next point, we're going to say that that's 1 unit in time. So I'm going to have time, I'm going to have x, and I'm going to have y. Maybe if I make a chart here, I can figure this out. So at time equals 0, what's my x value? -2. What's my y value? +5. So I want to advance forth 1 unit in time. How should I change my x? How should I change my y? So how should I change my x? Add 1. How should I change my y? Add 4. You see that? So the slope is 4 over 1. So that's rise over run. So we're going to change the run or the x. We're going to change it 1 unit. We're going to change the rise 4 units. So let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so on and so forth. So if I advance 1 unit for x and I advance 4 units for y, 1, 2, 3, 4. What's that new coordinate? So time is 1 and the x value is now -1. What's the y value? 9. I'm going to advance another unit in time. What do I change the x to? 0 and the y is 13. I advance another unit in time to 3. What's the x going to be? 1. And what's the y going to be? 17. Everybody see the pattern that's developing? Okay. So we want to then write an equation of parametric form that maps that. So we will do that. We will say x sub t is equal to something. And we'll say y sub t is equal to something. Yes. How I got like -1, 9?
I don't like, you went up, is it like every 4 you're going up, but you said 13?
So look at what the y is changing by each time. Look what the x is changing by each time.
So are you plugging that in together? Or
Nope.
like, you're just going
Yep, I said x is going to go by 1 because of this. And y is going to go by 4 because of this. Better? Okay, so now I'm going to write an equation for x. I'm going to write an equation for y. Okay? As t goes up by 1, what does x go up by? 1. So the slope for x is 1. As t goes up by 1, what does y go up by? So the slope for y is 4. Now we've got to get our starting point, okay? All right? If you plug in 0 for t, what does x come out to be? If you plug in 0 for t, what does x come out to be? -2. If t is 0, x is -2. Everybody agreed? So if t is 0, x has to be, so what do I need to do? -2. If t is 0, what is y? 5. So if I plug in 0 for t, I have to come up with 5. So what do I need to do? Add 5. Now let's just check our work. Let's check this guy right here. If you plug in 3 for t, you should get 1 for x. If I plug in 3 for t, do I get 1 for x? Yeah, and if I plug in 3 for t, I should get 17 for y. If I plug in 3 for t, I do get 17 for y. That checks out, doesn't it? And in fact, if we go back to our calculator and we turn it on, we can go into y equals, and we can change that to t minus 2. And we can change that to 4t plus 5. And hopefully I get a line. Look, my line starts at -2, +5, and it heads up just like we thought. So we wrote an equation for that line in parametric form. We could do all sorts of equations. For example, we just did a line. We could do parabolas. We could do circles. We could do ellipses. We could do all sorts of things. We're just saying we just want to be able to do one example, a line. That should be enough. All right. I will be printing off your study guide and giving it to you tomorrow. Pending the weather, we'll see what we do in class. But for you seniors, that was maybe the last math lesson you ever had. Or you're going to cry?
Yeah.
All right, thank you. I'm getting emotional as well.